dear students, welcome in our channel Class 10 NCERT SSC Math with Sujatag. Let us study the examples on the basis of the congruent chords. A, B, C are any points on the circle with center O. Write the names of all arcs formed due to these points. So here in this figure there are the 3 points A, B, C which are lying on the circle, and we have to write down the name of all the arcs made by these points. And the second question, that is the if major arc BC is equal to 110 and major arc AB is equal to 125, then we have to find the measure of all remaining arc. Okay student, so let us see how we can solve this example. So first here, names of arcs, that is arc AB, arc BC, that is arc BC, then arc AC, this arc AC, then arc ABC. Now in the 3 letters, that is arc ABC, we can write the letters as the 2 letters, the name of the arc as in 2 letters as well as in 3 letters also. So that means the arc AB we can write also arc ABC, arc BC, arc CA, then arc BCA, and then arc CAB, such a way. Okay, so these are the names of the arc. Now the second point, that we have to find out the measure of arc ABC. How can we find out the measure of arc ABC? So make the formula, that is measure arc AB plus measure arc BC. Now the measure arc AB plus measure arc BC. Now we know the values of measure arc AB, that is a 125, and the measure arc BC, that is equal to 110. So their sum is 235. So the measure arc ABC is equal to 235. Now here secondly, that is we have to find out measure arc AC. This one student, this we have to find this arc. So make out the formula, that is the 360 degree minus measure arc ACD. The 360, that is the measure of the whole square is 360 minus this ABC. So now here measure arc AC is equal to 360 minus 235, because we already calculated the measure arc ABC as 235. So 360 minus 235 is equal to 125. Okay students, and then here the next one, that is measure arc ACB is equal to 360 minus 125, which is equal to 235, and the measure arc BAC is equal to 360 minus 110, that is equal to 250 students. Second example students, in the figure a rectangle PQRS is inscribed in a circle. With center T. Prove that first one, arc PQ, this arc PQ is congruent to arc SR, and the second arc SPQ is congruent to arc PQR. Okay, so now here how can we prove this theorem? So first write down, that is the PQRS is a rectangle students. Okay, this PQRS is a rectangle. So here we can say that chord PQ, is congruent to chord SR. And why is it so? Because opposite sides of a rectangle are congruent, and that's why these are the chords. PQSR becomes the chords, and so PQSR becomes the chords. That means the arc, that is the PQ arc and the SR arc, are congruent. Okay students, and then arc PQ is congruent to arc SR. That means the arc corresponding to congruent chords. So now the chords arcs are equal. Now the second part, that is the chords PS is congruent to chord QR also, because these are the PS and QR the opposite side of the rectangle also, and they are equal. So as they are equal, that means the arc PS and the arc QR are congruent, because arcs corresponding to congruent chords. So that means measures of arc SP and QR are equal. The next topic, student, that is the inscribed angle. So here in this figure, C is the center of the circle. C is the center of a circle. The vertex D of angle PDQ. See here, the vertex D. See, that is here, the vertex D is of angle PDQ, okay, and lies on the circle. The arms of angle PDQ, intersect the circle at A and B, okay, that intersect the circle at A this point and at B at this point to the circle. So such an angle is called an angle inscribed in the circle or in the arc. Okay, so this angle is called as the inscribed angle, okay, in the arc. So that means angle ADB is inscribed in the arc AB, Angle ADB is inscribed in the arc AB. See the next topic, student, that is the intercepted arc. Now see in front of you there are the 6 figures, and in these figures the arc of a circle that lies in the interior of the angle ABC. The arc of a circle lies in the interior of angle ABC is an arc intersected by the angle ABC. Okay, so now here observe the arc which lies in the interior of the angle ABC. So here in the first figure we see that arc AC lies in between the angle ABC here. Also here that in the second example figure that arc BC lies in the interior part of the angle ABC. In the third figure that arc AC lies in the angle ABC. In this fourth one figure that arc AC lies in between this angle ABC. In the fifth one figure also that arc AC lies of the angle ABC, and here also in the sixth one figure that arc AC lies in the interior part of the angle ABC. So now here we can say that these are the arc intersected by angle ABC. So these are the arc intersected by angle ABC. But here if you observe carefully, that then we can say that from the figure first, second and third, we can say that only one arc is intersected by the angle. Okay, only one arc is intersected by the angle ABC here. Okay, but in the fourth, fifth and sixth, from these 3 figures, that we can say that 2 arcs are intersected by the angle. Two arcs are intersected by the angles. Okay. So which are these two arcs? That is this one arc AC and this one arc. Okay. Here this one arc AC and as well as this one arc. Okay students, and observe this carefully. Which part is there? This arc AC and this portion is also AC. So the two arcs are intersected by the angle. Okay students? The students theorem, and that theorem is known as the inscribed angle theorem. Okay, so what is the statement of this theorem? The measure of an inscribed angle is half of the measure of the arc intersected by it. So from the statement we draw the figure. Okay, that given in from the figure we write down the given. So here given is in a circle with center O, angle BAC. See here, angle BAC. See here, this one is the angle BAC, is the inscribed in arc BAC. So observe this figure students, that in this circle there is a center O, okay, and here angle BAC. Angle BAC is this, and it intersects the arc BAC. It intersects the arc BAC. Okay, and here the arc BDC. That there is a arc BDC. This is the arc BDC, and this arc is intersected by the angle BAC. Intersected by the angle BAC students. Okay, so now here we have to prove that angle BAC is equal to half of major arc BDC. The measure of the angle BAC, this angle BAC is equal to half of this arc BDC. There is a construction student, that without construction that theorem cannot be proved out. So here we constructed that draw ray OA, okay, OA, and it intersects the circle at E. It intersects the circle at E. Okay, so draw radius OC. Draw radius OC. Okay, so now here we have the triangle, and that triangle is AOC. That triangle is AOC students. So in the proof we can start from the triangle AOC. That in triangle AOC, okay, side OA is equal to side OC. Side OA is equal to side OC. This is the first point, because these are the radii of the same circle, so they are congruent. Then the second is the angle OAC. This angle OAC is congruent to angle OCA. Okay, it's congruent to angle OCA because the theorem of isosceles triangle. Now the length we have to consider that angle OAC is equal to angle OCA, and which is equal to x, and call it as the first equation. Okay, then here angle EOC. Then see here the angle EOC is equal to angle OAC plus angle OCA. See here angle EOC is equal to angle OAC, this one angle OAC, and plus angle ACO. Why is it so? Because the angle EOC is the exterior angle of the triangle OAC. Okay, and so it is, we write as the angle EOC is equal to angle OAC plus angle OCA. So now here we consider the angle OAC and OCA as a x degree. So here x plus x, that means the 2x degree. So angle EOC is equal to 2x degree. Okay, so then EOC is a central angle. Observe the figure, students, that EOC is a central angle and that major arc EC, then the arc is also equal. That is, the angle arc inscribed in this angle is also equal, and that major arc AC is equal to 2x degree. So now here from equation 1 and 2. So this equation call it as the second one, and we have the first equation earlier, and then we can say that from the first and second equation, angle OAC is equal to angle EAC, which is equal to half of major arc EC. Okay, so called it as the third equation. So this way we have get the right part of the angle ABC. That means the angle EAC is equal to half of major arc AC. Now similarly, we can drawing the segment OB, and then we can prove angle EAB. Angle EAB is equal to half of major arc BE, and call it as the fourth one equation. So now here the sum up of the angle EAC and angle EAB. Then we have half of major arc AC plus half of major arc BE. Okay, so then common of half, that is the half of major arc AC plus major arc BE. So now what is the arc AC plus arc BE? Then it get the arc BEC. So now here that angle EAC plus angle EAB, that is equal to BAC. So here we write the angle BAC is equal to the 1/2 major arc BDC. Okay. Next theorem, student. The measure of an angle subtended by an arc at a point on the circle is half of the measure of the angle subtended by the arc at the center. So from the statement, first we draw the figure here. Okay, so now here there is an angle BAC, and in that angle BAC there is an inscribed arc, that is the BC. Here we first draw. Then students, angle BAC, see here angle BAC is equal to angle BAE minus angle CAE. Okay, so here angle BAE, that angle BAE means that half of major arc BCE, half of major arc BCE. Okay, and the angle CAE, we write that angle CAE as the half major arc CE. Okay, so now here half of major arc BCE minus here the common from these two, then half major arc BCE minus major arc CE. So now major arc BCE minus major arc CE, that means it is the BC. So here angle BAC is equal to half of major arc BC. The two corollary of inscribed angle theorem, student. The first one is that angle inscribed in the same arc are congruent. Okay, so now here see this figure, that in this figure there is a arc, PTR, there is a arc PTR, and in this arc the two angles are inscribed. See here is the angle PQR also. Okay, it include also this arc, and as well as the PSR, this angle also include the arc PTR. So here we can say that the angles inscribed in the same arc, the angle inscribed in the same arc are congruent. Okay, and the second one, see the second one corollary, that is the angle inscribed in a semicircle is a right angle. Okay, so angle inscribed in a semicircle. So here the semicircle, see the semicircle portion. So we draw here the diameter AC, and then this become the semicircle. Okay, this become the semicircle, and there is an angle. There is an angle ABC. We draw the angle ABC, and that angle is a 90-degree angle. That means an angle inscribed in a semicircle is a right angle. Students, thank you for watching our videos. Achieve your success with us. I am sure that you will get 100% success in maths. So watch our videos continuously, regularly. Like our videos, share our videos to your friends.